Hi everybody, today we're going to try to start talking about section 10.4, which is ellipses. We saw ellipses on the first day of the unit, and those are those ovals. So here we go. Some vocabulary to talk about ellipses. There's kind of a lot here, so I'm going to try to highlight everything as we go here. The center is exactly what you think it would be. It's the spot right in the middle. The major axis is the longest line here. So that's the one that has the two dots on it. The two dots are something else. That's this one. The minor axis is the one that goes top to bottom in this picture. It's the shorter straight line. The vertices are on the major axis, and the co-vertices are on the minor axis. And then the foci are the last one, and so I'm just going to point those out. These are the foci. The word foci is just plural of the word focus. Okay, so on this slide, I'm going to kind of start with the bottom here, and I'm going to label the distance from the center to the vertices. I'm going to call this A. And so what you have to know about this slide is that if you pick any point on an ellipse, maybe that one right here, I'm going to call this point P. I'm going to call this point F1, focus 1, and I'm going to call this point F2, focus 2. The distance from P to F2 plus the distance from P to F1 is equal to 2A. And so this distance from here to here to here is twice the length of from here to here. The spot where that's really important is right here. And so I'm going to create two right triangles from this point right here that I just drew. So you'll see this point and this point. And now we can see, oh look, these two are congruent, and we could do side angle side to show that these are congruent. Okay, so since those two triangles are congruent that we constructed on the last slide, I can conclude that these two hypotenuses, this one and this one, are congruent. And remember that the distance from here to here to here is 2A. And so that makes this one 1A. And so now we know that the distance from the co-vertex to the focus is the same as the distance from the center to the vertex. And now that's important because then we can use a right triangle to solve for the dimensions of the ellipse. And so if I call this length from the center to the vertex A, that's the same as this A. If I can call the length from the center to the co-vertex, I can call that B. And then I can call this length from the center to this focus here, I can call that length C. And if you remember back a little bit further to geometry, you're going to remember the Pythagorean theorem. And it says that the sum of the squares of the two legs of the right triangle, this is a right triangle right here, is equal to the square of the hypotenuse. And so what we can do is we can set up b squared plus c squared equals a squared. Now I know that's a different way of writing the letters a, b, and c in the Pythagorean theorem, but it's just kind of the way that we write the letters in the ellipses. If I get c squared by itself, I can subtract b squared. To do that, I get c squared equals a squared minus b squared. And that's exactly the equation that's written up here. On this slide, I have the kind of standard form of how to write an equation for an ellipse. You'll notice that the a and the b that we used on the last slide show up in this slide. And so a, remember, is the distance from the center to the vertices. And remember that b is the distance from the center to the co-vertices. Okay, and so we can see a and b here. When we have that a and b, then we can use our a and b to find c, which is the distance from the center to the foci. Notice here that our a is a bigger number than our b, and that's what makes it horizontal, because the a is a bigger number and it's underneath the x. If the a was a bigger number and it was underneath the y, then it would be a vertical ellipse. And here's kind of our setup for the vertical ellipse. So you'll notice that our a is underneath the y. Still, we have the same rules about what a and b are, so I'm going to write those again. A is my distance from the center to the vertices, and b is the center to the co-vertices. So I'm just going to draw a little diagram here. Here is my A from the center to the vertices. In the vertical ellipse, you'll notice that's kind of an up and down line. And then B is the center to the co-vertices. That's a right to left line. Our C is the distance from the center to the foci. And so again, we could set up that right triangle where we have the same length from the focus to the co-vertices. This is A, and then we have our right triangle again. Because of how we wrote the A and the B, we can keep the same two properties from the beginning of the lesson. Ton of information on this slide. I know I just wanted to put a set of formulas up here. You should screenshot this or save this or write it all down so that you have access to it. You can also see pages 639 and 640 in your textbook to see some more information about this. Just one example problem for us today. I want to sketch this ellipse given by this equation, and then I also want to find where the foci are. And so I'm going to start by, I'm going to label what A is. A is the bigger number, and so A squared is 169, which means that A is 13 because 13 squared is 169. And then B squared is 144, which means that B is 12. Okay, so I'm going to start by drawing my ellipse, and I'm just going to kind of sketch this with, so we'll see how this goes. Here's my ellipse, and it is actually a vertical ellipse, and I know that it's vertical because the y has the number that's bigger underneath it. So I'm going to draw it like that. Because B and A are really close, I tried to make it pretty close to a circle, but not exactly. So I'm going to draw my major axis and my minor axis like that. This minor axis is from here to here. I guess I should do it in blue. From here to here is 12. From here to here is 13. And we have to figure out what the distance is from here to here where the focus is. I don't know where the focus is, so I'm kind of guessing. But what I do know is that this is like that. Okay, so this is 13, this is 12, this is my C, which is my length from my focus to my center, and that's the thing I need to find. I'm going to set up my Pythagorean theorem. So I'm going to say, okay, C squared plus 12 squared equals 13 squared. And so I have 169 equals 144 plus C squared. I'm going to subtract 144, and I get 25 equals C squared, and so I get C equals 5. Okay, so C equals 5, which means that the foci here and here are at the points 0, 5, and 0, -5. The vertices are 0, 13, and 0, -13. And then the co-vertices are at -12, 0, and 12, 0. Okay, so here's a sketch of the ellipse. I guess I should say that the center is at 0, 0. Here's a sketch of the ellipse. I have labeled the foci here and here. I have labeled the vertices here and here, and the co-vertices here and here. I found the focal length, the C, using the Pythagorean theorem, and so I'm done with this problem. That's all I got for you today, so give the assignment a shot, and I'll see you tomorrow.